Alright, so in this video I'm gonna demonstrate how to write a binary search tree in Java. So in this demonstration we're gonna create three classes, one for the node, another one for the actual binary search tree, and another one for the demonstration class with the main method. So for this we're gonna create firstly a folder called this BST, and in this folder we're gonna create our first file, which is the node.java. The class node will have three properties. In a binary search tree, every node will have at most two child nodes, the left and the right child nodes. So, and then the third one would be the value, which is an int. So here we're gonna declare a node left and right, and the int will be the value. Of course, we need to create a constructor, and in the constructor we are going to pass a parameter int, which is the value that will be the value of the node, and of course this is this that value equals value, and that's it for the node, nothing else. So now let's move on to writing the binary search tree class. Okay, so here for our binary search tree we only have one property, which is the root node, and of course in our constructor we just initialize the root node with null. So the first method we're gonna have to do is the insertion method, which will be a two-part. One is the public insertion method, which allows us to insert from the root, and private insert method that will insert it recursively, because this is a tree. So let's do first the recursive method. It can be private, and it will return a node, and we call this insert node. This will have two parameters, the value, which is an int, and the node where it is going to be inserted. Now if the current node is blank or empty, or null, we are going to return a new node here, which will have the value that we inserted. However, if that's not the case, we're gonna have to check if the value is greater or lesser than the current node, and so that we will move either left or right. So in that case, if current node that value, if it's greater than the value that will be inserted, we're going to move to the left. So current node dot left is equal to insert node. So here's the recursive call here, value, and now the current node, the node that will insert it will be the left node. Otherwise, we're gonna have to call current node dot right, insert node, again the value, and this time current node dot right. And then at the end we'll simply return the current node. Okay, now the public method, the method that is going to use to insert from the outside, public void insert, will only have one parameter, the value, and this will simply call the insert node right from the root. So root is equal to insert node, the value, and the root. So that's how insertion is done. Now let's move on to in order traversal. Public void in order. This will need to have a node passed here. Now with the in order traversal, we go left, we visit, and then we go right. But of course, we don't do anything if that node is empty or null. So first, if node is not equal to null, that's the time we go to the left. And going to the left simply means calling in order on the left node of this node. So simply call in order node dot left, and then do the visit, which in this case will simply be displaying the value. So node dot value, we'll just add some comma, and then after visiting we go right in order node dot right, and that's it. So now let's test this. We create a new class for which have our main method. Call this class demo.java. So first we declare a binary search tree, and we also declare some values to be inserted. We just put it in an array, make it simple. Okay, and then we loop across this array and insert it into the tree. Let's have a message first. Inserting, then here we have tree dot insert x, and let's display a message that we're inserting this x here. Okay, now let's display it using the in order traversal. So simply call tree dot in order. Of course, since it's going to need a node, we'll simply call tree dot root. And let's try this. demo.java. Alright, we have no error. So run java demo. Okay, so here we are inserting 3, 7, 5, 66, 8, 22, 3, 44, 2, 56. And in the in order traversal, we have 2, 3, 3, 5, 7, 8, 22, 44, 56, and 66 displayed in sorted order. So that's it. Thank you very much.